rendering the scene. Once the shaders are established, the locations are looked up, and the square plane's vertex positions put in a buffer, we can actually render the scene. We'll do this in a draw scene function that again we'll implement in a separate JavaScript module. So create a new file called draw-scene.js and give it the following content. So we're gonna go into the VS Code, and we already have two JavaScript files, so we're gonna have a third one that is gonna be draw-scene.js, and we're gonna start typing some code here. So we're gonna have in this function, so it's gonna be function, and we're gonna name it draw. We're gonna name it draw scene like this, and it's gonna have some parameters. It's gonna have the GL comma, and it's gonna have program info. It's gonna be program info like that, and also it's gonna have the buffers. Okay, so outside of that, we are now open curly braces, and we're gonna have the GL that, and it's gonna be clear color. It's gonna be clear color, and inside of the parentheses we're gonna have in 0.0 comma 0.0 comma 0.0 comma and 0.1. Let me see, we 0. Okay, that's fine. We're gonna end it up with a semicolon at the end, and okay, you have this comments clear to black, fully opaque, and we're gonna have the GL that, and this time it's gonna be the clear. It's gonna be clear depth like that, and we're gonna open parentheses 1.0. Okay, clear everything. Then we're gonna have in third one is gonna be GL that enable like that, enable, and we're gonna pass in just one parameter. It's gonna be GL. It's gonna be GL that, and it's gonna be depth underscore this. It's gonna be depth underscore this like that. Depth underscore this. We're gonna end it up with a semicolon, and the second one as well. Okay, so we're gonna have a fourth one. It's gonna be GL that, let me see, it's gonna be GL that depth function. Is gonna be depth, okay, like that, depth function like this, and we're gonna open parentheses. We're gonna have the GL that, and it's gonna have L equal like that, L equal, and then we're gonna put a semicolon at the end. Okay, so the clear, there's one clear depth, clear everything, enable depth testing, GL that depth fun, near things, obscure far things. So now we're gonna copy this comment, and we're gonna move below. So we're gonna have in the clear the canvas before we start drawing. Okay, so we're gonna clear the canvas before we start drawing, and we're just gonna have this piece of code that is gonna be GL that, let me see, it's gonna be GL that clear. Okay, GL that clear. We're gonna open parentheses. We're gonna use the vertical sign, and let me see, we're gonna have okay, first of all we're gonna have the GL that, and it's gonna be color underscore buffer. Okay, and the underscore bit, we're gonna use the vertical sign or the OR operator, and then we're gonna have the GL that, and again it's gonna be the same we have color underscore buffer underscore bit, then we're gonna have depth underscore buffer underscore bit. So it's gonna be depth underscore buffer underscore bit, and there with a semicolon at the end. So we have that, and now we have these comments. So let's just copy the comments. Okay, let's go here, and let me see. So create a perspective matrix, a special matrix that is used to simulate the distortion of perspective in a camera. Our field of view is 45 degrees with a width height ratio that matches the display size of the canvas, and we only want to see objects between 0.1 units and 100 units away from the camera. So we have that, and to do that we're gonna create some variables. So let's start doing that. Let's move it. I'm gonna move here, so it's gonna be cons, and this variable name is gonna be field of view. So it's gonna be field of view, and remember camel notation, and we're gonna set it to something. So we'll open parentheses, and okay, this is gonna be a division, and then we're gonna end it with a semicolon here. Okay, so we're gonna have in 45, and we're gonna multiply it, so maybe a space here. We're gonna multiply it by the math, and okay, math that pi, like this. Okay, and then we're gonna divide it by 100, like this, and we're gonna put semicolon at the end. So this is in radians, so we have field of view. Okay, and radians, we're gonna have another one. We're gonna have the const, and this time is gonna be aspect, like this, and we're gonna set it to GL. We're gonna set it to GL that canvas, like that, and it's gonna be that client. Let me see, there's gonna be that client width, like that. So it's gonna be GL that canvas that client width, and we're gonna use this division, and it's gonna be GL, and it's gonna be that canvas, and it's gonna be that client height, like this, client height, and we're gonna end it with a semicolon. Okay, so we have the aspect. The aspect is going to be the GL that canvas that client height divided by the GL that canvas that client the width divided by the height. So the next one is going to be const. So we're going to create a variable named z near. So it's going to be z near. We're going to set it to something, and it's going to be 0.1, like that. Ended up with a semicolon. We're going to have another one. It's going to be const, and it's going to be z far, like this, and we're gonna set it to 100 that's 0. Okay, so like this, we're gonna create a final variable, and we're gonna name a projection matrix. So it's gonna be projection, okay, projection matrix, like that. We're gonna have the projection matrix, and we're gonna set it to mat4 that create function, like this, and there with a semicolon. Okay, and now we're gonna have in some comments here, so I can go below. Know that GL matrix.js always has the first argument as the destination to receive the result. So we have that. Let's keep coding. So we are gonna have in the mat4.perspective. Okay, so let's move it here. We're gonna have in the mat4.perspective, and we're gonna set it to something. mat4, oops, it's mat4.perspective. We are setting to the let me see, we're just passing in some arguments here, and these arguments are the projection matrix. So it's going to be projection matrix inside of the parentheses, so like that, projection matrix. What else do we have? So we're going to have in the field of view. So it's going to be the field of view, and then it's going to be the aspect. So it's going to be the aspect, and field of view, the aspect, and we're gonna have in the C near, and finally the C far. Okay, so we have that. Now we're gonna have some comments here, so let's just grab those comments and let's move here, let's paste it. Set the drawing position to the identity point, which is the center of the scene. Okay, so we have that. Let's okay, so let's start coding here. We're gonna have this variable name model view matrix. We're gonna have in guns, and it's gonna be model view matrix. We're gonna set it to something. Okay, it's gonna be model view matrix, and we're gonna set it to the mat4 that create. So the mat4 that create, we're gonna set it ended up with a semicolon at the end. Okay, and below that, so we're gonna have some comments. Now move the drawing position NIB to where we want to start drawing the square. So let's move it here. Let me see, let's move those lines, those comments here. Okay, so we are gonna start typing here. So let me see, we're gonna have in this mat4.translate. Okay, so it's gonna be mat4.translate. We're gonna open parentheses, and inside of the parentheses, what we are gonna have is gonna be the model view matrix. Okay, model view matrix separated with a comma. We're gonna have again the model view matrix, again separated with a comma. And now we're gonna have this array, and it's gonna have the values, three values, negative 0.0, comma 0.0, and finally 0.6, negative 0.6. So we have that. Okay, we can save it for the time being. What else do we have here? So we ended up this statement with a semicolon, this mat4.translate. Okay, I'm out to translate. Now we'll have some code, some comments. Let's copy those comments below, and we have tell WebGL how to pull out the position from the position buffer into the vertex position attribute. So let's do that. Okay, so set position attribute. So let's do that. So set position attribute. Okay, set position attribute, and we're gonna pass in some arguments. That is gonna be the GL, it's gonna be the buffers. Gonna be the buffers, and it's gonna be the program info. Okay, so I already have those, ended up with a semicolon. Now we're gonna tell WebGL to use our program when drawing. So now let's just copy this comment here. So let's put it in, well, you already have it this in GitHub, so let's put some comments. So tell WebGL to use our program when drawing. So it's going to be GL that use, okay, use program. So use program. Okay, GL that use program, and we're passing them program info. It's going to be program info, and also we are passing in program info that program. So like that, GL that use program, in the parentheses we have program info that program. So we ended up with semicolon at the end. Save it. What else do we have here? So now set the shader uniforms. Okay, set the shaders uniform. So let's just copy this comment, and let's just move here. Now okay, it's gonna be GL that uniform matrix. So let's try it. So it's gonna be GL that uniform matrix, GL uniform matrix, matrix 4 for FV, like that. FV. We're gonna open parentheses, and inside of the parentheses we're gonna have the program. It's gonna be the program info. Okay, so we have that. We have the program info that uniform, the uniform locations, and then it's gonna be that projection matrix. We ended up with a comma, or we separated with a comma. Okay, so we have, let's move it here, set the shader uniform, set the shader uniform. Okay, so we have the gl.uniform matrix for fb program info that uniform locations that projection matrix separated with a comma. We're gonna have in false comma. We're gonna have in projection matrix. So it's gonna be projection matrix, another comma. And okay, so we close the parentheses, we put a semicolon at the end, so we have that. And okay, so now we're gonna see the gl that uniform matrix. Okay, so below here, gl that is gonna be uniform matrix, okay, 4. So we're gonna open parentheses, and inside of the parentheses we're gonna have the program info, and program info that uniform locations. So it's going to be uniform locations that projection matrix, that no, it's going to be model view matrix. Okay, model view matrix. Let's delete this, and it's going to be program uniform locations, and it's going to be model view matrix, like this, comma here. Then we're gonna have a false, and we're gonna have model view matrix. We put a comma here, and here we're gonna end it up with a semicolon again. We have that. And now we're gonna open an empty set of curly braces. So we're gonna have in this object, so we're gonna have in this cons, and we're gonna set it to 0. So cons, I mean the offset, so it's gonna be offset, and we're setting it to 0. Okay, so we have this variable name offset, setting it to 0, semicolon at the end. We have another cons name vertex, is going to be vertex count, and we're going to set it to something. It's going to be 4, semicolon at the end, vertex count. Then we're going to have the gl, that is going to be draw arrays. We open parentheses, we're gonna have the gl that triangle is gonna be triangle underscore strip. Okay, so now it's gonna be the offset. Okay, it's gonna be offset, and then vertex count, so it's gonna be the vertex count, like that. So we can save it. And offset, okay, it's gonna be this one. It's not camel notation. Okay, so we don't have that error. Okay, so we ended up here the system with a semicolon, and outside of these curly braces we're gonna continue our code. Let me see. Okay, so outside of these curly braces, now we're gonna have we're gonna paste these comments here, and here we have tell WebGL how to pull out the positions from the position buffer into the vertex position attribute. So let's do that. So we're gonna have this function set position attribute. So we're gonna have in the function, and it's gonna be set position attribute, like this, and we're gonna set it. We're gonna, inside of the parentheses, we're gonna pass in the GL, we're gonna pass in the buffers, we're gonna pass in the program info. It's gonna be program info. We're gonna open curly braces, and we're gonna have in some variables. So we're gonna have in this variable comes, it's gonna be the num components, and we are gonna set it to 2, semicolon at the end. So pull out 2 values per iteration. Okay, Okay, num components. Okay, so now we're gonna have in the counts, and we're gonna have in the type, and we're gonna set it to gl dot, and it's gonna be float gl. Okay, type, and it's gonna be gl dot float, and again ended up with a semicolon. The data in the buffer is 32-bit float, so then we're gonna normalize it. We're gonna have this variable name. It's gonna be name normalize, and we're gonna set it to false. Okay, so the normalize, we're gonna have this variable name stride, and we're gonna set it to something. Stride, we're gonna set it to 0, semicolon at the end. How many bytes to get from one set of values to the next? 0 is equal to just type in components above. Then we're gonna have this variable, the counts offset, and we're gonna set it to 0, semicolon at the end. Okay, how many bytes inside the buffer to start from? Then we're gonna move to the gl dot. It's gonna be gl dot bind buffer. It's gonna be gl dot bind buffer, and we're gonna open parentheses. We're gonna pass in the gl. We're gonna pass in, okay, it's gonna be gl dot array, and it's gonna be underscore buffer, like this. We're gonna pass in a comma. We're gonna separate it with a comma. We're gonna have in the buffers, and it's gonna be that position. Buffers that position. So ended up with a semicolon. We're gonna have again gl dot, and it's gonna be vertex. It's gonna be vertex attribute pointer. So it's gonna be vertex attribute. Gonna be vertex attrib, so like that, attrib, and then pointer. We're gonna open parentheses, and inside of the parentheses we're gonna have in this program. It's gonna be the program that it's gonna be the program that info program. Okay, program info that attribute. So I don't have it here. It's gonna be attrib locations that vertex position, positions. Okay, position. We separate with a comma. Then we're gonna have in the nums components separated with a comma. We're gonna have in the type separated with a comma. We have the normalize separated with a comma. Normalize. We have the stride separated with a comma. We have the offset separated with a comma too. Okay, and we're gonna go down, semicolon at the end. Okay, okay, let me see something. Let me see if this is right. So it's gonna be program info. Okay, camel notation, vertex attribute pointer, program info that attribute locations that vertex position. Okay, yeah, that's fine. Okay, outside of this parentheses, outside of the vertex attribute, we're gonna have something else. It's gonna be the gl dot, and it's gonna be enable vertex. It's gonna be enable vertex attribute, okay, attribute array, and inside of the parentheses we're gonna have in the program info comma, we're gonna have the attribute locations. It's gonna be attribute locations. Okay, I have it now. Attribute locations that vertex position. Okay, program info that attribute locations that vertex position. Okay, Okay, so that's fine. And then this is this statement with a semicolon. Okay, so we have this final curly braces, and outside we're gonna export it, so it's gonna be export, and we're gonna export the draw scene, so it's gonna be inside of the curly braces. We're gonna export the draw scene, so we have that. And up to this point nothing has changed here, but we're almost done here. So the first step is to clear the canvas to our background color. Then we establish the camera's perspective. We set a field of view of 45 degrees with a width to height ratio that matches the display dimensions of our canvas. We also specify that we only want objects between 0.1 and 100 units from the camera to be rendered. Then we establish the position of the square plane by loading the identity position and translating away from the camera by 6 units. After that, we bind the square's vertex buffer to the attribute the shader is using for the A vertex position, and we tell the WebGL how to pull the data out of it. Finally, we draw the object by calling the drawArrays method, so we have that. Finally, let's call init buffers and draw scene. So this is the functions. Add this code to the start of your WebGL -demo.js. So we are pretty much done with this code. Let's go back to the basics. So this WebGL-demo.js, so we have that. And okay, so we're gonna have now add this code to the start, so it's gonna be to the start, so it has to be before main. Okay, so what we are gonna do is we're gonna since here we are exporting something, so we're exporting. In this case we're catching it or just importing, so we're gonna import. So we're gonna import, and it's gonna be in curly braces. It's gonna be init, so I already have it. Okay, so I did it for me. Init buffers from, okay, that's fine. Now we're gonna import it again, so we're gonna import, but this time it's gonna be the draw, so it's gonna be the draw. Let me see, draw scenes. We're gonna let me see, import, and it's gonna be draw. It's gonna be draw scene like this, and this is gonna be from, and let me see, it's gonna be from draw scene like that. Let me check real quick the draw scene. So draw scene, let me see if maybe I didn't type something right. Okay, function draw scene, yeah, it's fine. So it didn't do it automatically for me, but just so now we're in the final stages. We're gonna import init buffer and draw scene. So we're gonna go to Visual Studio Code, and we're gonna go into the WebGL -demo.js, and we already did that. And we are importing the init buffer, and it's gonna be from the init buffers, and it's gonna be .js like that. And also we're gonna import the draw scene, so, and it's gonna be from the draw-scene.js. okay, so we did that. Okay, add this code to the start of your WebGL demo file. We did that. So finally, to end this, we're gonna add this code to the end of your main function. So again, we are in the WebGL-demo.js, and this is our main function. This is the curly braces, so I'm gonna just click in this curly brace, and as you can see, it's becoming green. So I'm gonna go down, and this is the end. So just before the end, what we are gonna do is, this is where we're gonna have the code. I'm just gonna copy this comment. I'm just gonna paste just the comment, and pretty much oops. So here is where we call the routine that builds all the objects that we'll be drawing. So here is where we're gonna type in our code, and we're gonna have this variable name. It's gonna be counts, and it's gonna be buffers like that, buffers, and we're gonna set it to init buffers. Okay, and we're gonna pass in the GL like that, and then we're gonna end it with a semicolon. Okay, then we're just gonna have the draw scene, and let me see, we're gonna just draw scene, and we're gonna pass in this parameter that is gonna be the GL, is gonna be the program info, and finally it's gonna be the buffers. Okay, so we're gonna save it, and let me see, well, I'm just gonna press Alt plus L plus O. So okay, as you can see here, this is so far our final product. So let me see, the result should look like this. So now, before just we have a big black box, now we have a white box inside of the black container, and we can open it, and we can see we are in the right track. And again, this is just the beginning. For at the end, we want to put some code that is gonna make it into a square rotating, so kind of like a 3D. And what else do we have here? So this is the code, you can check out. And then we have the matrix utility operations. Matrix operations might seem complicated, but they are actually pretty simple if you take them one step at a time. Generally, people use a matrix library rather than writing their own. In our case, we are using the popular GL matrix library, so we can check out all this information here.